Hello everybody, today we will talk about compositions of transformations. It is a combination of two or more transformations, each performed on the previous image. Okay, there is what we call a glide reflection. What is a glide reflection? It is the composition of a translation followed by a reflection across a line which parallel to the translation vector. The most important example on a glide reflection is your footprints in the sand, like this picture, your footprints on the sand. This is an example of a glide reflection. Okay, let us go to the word lesson. Sorry for this. Okay, now how to draw compositions of isometries, because we will talk about translations, refractions and rotations. So we will make combinations of isometries only. This is the first example. Reflect the triangle ABC across line L, then translate it along the vector V. This is our triangle ABC. I want to first reflect it across this line. This is the line of reflection. Then I will translate the image. This is the second transformation. The first is the reflection. Then I will translate it along this vector, okay, which is V. Okay, now we will reflect it. If you remember about reflection, how we did it before, first you have to draw the perpendicular lines from each vertex from this triangle. I drew this perpendicular line segments. So this is a right triangle, and also this, and also this. I drew it from these three vertices from this triangle. Then I will now find the image. First I have to find the distance between point A and the line of reflection. Then I make it here. So this is the image for A, this is A prime, and the same thing from the line of reflection to point B, then find it here. So this is B prime, and the same thing for the last vertex, which is C. Then find it here, I did it before. This is C prime. Then I will connect between these three new vertices to get my first image. This is the image after the first transformation, which is the reflection. So I reflected this across this line. Now this is the image. Now I will, this is the pre-image, the original triangle, and this is the image after reflection, which is the first transformation or the first isometry which I did. Now I will translate this, the image, the new image which you got it, I will translate it along this vector. So you remember how we did this before also. I will, from each vertex, I will draw three, because we have three vertices, three lines parallel to this vector. Okay, so from the first, look, it must be parallel, and the second from B also parallel, and the third, which is also parallel. Then I will find what is the length of this vector. So I will move distance, I will move, it's 2.5 centimeters, so I will translate each vertex for 2.5 centimeters along these parallel line segments. This here. So this is the first image. This is C prime, so this is, I will call it C double prime, because this is the second transformation. Also from point B prime, I will move 2.5. So this is the second, which is B prime, B double prime, sorry, and the third for A prime, 2.5, it's here. So this is A double prime. Now this is our second isometry, which is the translation. Okay, so this is the last image which I got it. It's A double prime, B double prime, C double prime. By the way, all of these triangles are congruent to each other, because the first is the reflection. The reflection, it is isometry, and the translation also is isometry. So from the first image till the last image, I got also isometry. These two triangles are congruent to each other. That means the isometry, it satisfies that transitive property. Transitive property means if any shape is isometric to another shape, and the other shape isometric to the third shape, so the first is isometric to the third, so it is transitive. That's the property for isometries. Okay, so you can skip it. So the last image which I got it, this one. This is the composition of transformations. Now, how about transformations in the coordinate plane? You remember it before. Let us take this example. Triangle JKL has vertices J, 1, negative 2, K, 4, negative 2, L, 3, 0. Now, I want from you to reflect the triangle JKL across the x-axis. This is the first transformation, or the first isometry. Then rotate, this is the rotation, also it's an isometry. It's 100 degrees about the origin. You remember these transformations, we took it before. Okay. The first thing which we will do it's the reflection across the x-axis. You remember the rule? Any xy, any pre-image xy coordinates, it's will be any pre-image, the image will be x and negative y. If you reflect it across the x-axis, you will keep the x coordinate, but you will change the sign of y coordinate. This is the first transformation, the first isometry will I do it. The second one, after you get this, you will do the rotation 100 degrees above the origin. You remember also the rule about the origin. Any xy, you will get negative x and negative y if you rotate it about the origin 180 degrees. So I make this table for our triangle here. This is the pre-image, the original image, J1, negative 2. The first transformation, which is the reflection across the x-axis, each xy will be x negative y, so 1 negative 2 will be 1 positive 2. This is the first image. This is J prime, sorry. K prime, it will be 4, it was 4 negative 2, it will be 4 and 2. And L prime, L is 3 0, so L prime will be 3 0, 0 will not affected by negative sign because it's 0. Now I will make the second isometry, which is the rotation about the origin 180 degrees on these new images. So this is L prime. If you rotate it 180 degrees above the origin, you will get negative x, negative y. So it will be negative 1, negative 2. Also for this is J double prime. Now this is L prime. Rotate it 180 degrees above the origin, you will get negative 4, negative 2, and this you will get negative 3, 0. So the first pre-image, which is the original one, J will be negative 1, negative 2 after 2 transformations, and K will be K double prime, this one, and L will be L double prime, this one, and this is the middle transformation, which is the first one. The first transformation. Now I will draw these shapes. So 1, negative 2, 1, and negative 2. And 4, this is J, 4, negative 2, 4, negative 2, also this is K, and L, 3, 0, 3, 0, this is L. So this is the triangle. After composition, it will be like this. So I will skip this because this is the first transformation. Then I will draw the last one, which is the second isometry, because he wants this. You can draw all of these, but no need. So you will reflect this across the x-axis. It will be here. Then you will rotate it 180 degrees. The last image will be here, which is negative 1, negative 2, and negative 4, negative 2, and negative 3 with 0. This is JK, L, and this is the image, the last image, which I got it. Look, these are congruent to each other. The first transformation, which is the reflection, it is here. You can draw it. but no need. You will draw the first, which is the pre-image, and the pre-image and the image, the last image which you got it. Okay. Now let us talk about something else. I will talk about this. Now look at this example. This is the original shape, which is the pre-image. I reflected it across this line. I got this. Then I make a second reflection. Then I got this. Now, if you cover this the first image, now I got from the first, the original shape, which is the pre-image, and the last image, it is look like a translation. Look, this translation. And this translation, if I make it like this, exactly, yeah. And this translation, by the way, it is, I translated this this pre-image, which is this triangle, I translated it along this vector, which is perpendicular to these two parallel lines, which I make the reflection across them. So this is the perpendicular line. I make a translation along this vector, which is perpendicular to the parallel lines, which I make the reflections across them, and the distance which I moved it is double the distance in between these two parallel lines. If this 5 centimeters, this distance will be 10 centimeters. So I can get a translation from two reflections across two parallel lines, and the translation will be along vector which is perpendicular to the two parallel lines, and the distance for this translation, it is double or twice the distance between the two parallel lines. Okay, this is the first thing. So this is a theory. There's another theorem. So any two reflections across two parallel lines, you will get a translation. This translation, it will be along vector which is perpendicular to these two parallel lines, and with distance equal double the distance in between the two parallel lines. This is the first theory. The second theory, if I make a reflection, look, if I make reflections across two intersecting lines, not parallel, these are two intersecting lines, I make two reflections. This is the first reflection, and this is, I reflected this again across this line. So two reflections across two intersecting lines. Now if I cover the middle image, which is this one, look what I got. I got a rotation. This is a rotation. This rotation, its center is this point, which is the point of intersection of these two intersecting lines, which I make the reflections across them. And look about the angle which I rotate these two images around them. This angle, if you find the measure of the angle in between the two intersecting lines, look, I will find this angle. It's, look, 0, 10, 20, 30, it's 60 degrees. 60 degrees. Now, after covering this middle shape, now I want to get the angle in between for this rotation, which I got it. Now I connect between the center of rotation, which is this point, let us name it P, and this pre-image C, and you can connect between any two pre-image and its image. So this between C and C double prime, and I connect between through these two line segments. Then I want to find the measure of this angle. Look, you have to put the center of this protractor on the center of rotation, and you have to line up this. Now look here, up to this second side, it's 120 degrees. It is double the measure of this angle, which is 60 degrees. So this is the second theorem. You can get a rotation from two reflections across two intersecting lines, and the center of the rotation, which you get it is the point of intersection of these two intersecting lines, and its angle, whatever this angle, if it is clockwise or counterclockwise, no problem. And the measure of this angle, the angle of rotation, it is double the measure of the which is in between the two intersecting lines. So I can get a rotation from two reflections. And here, the first theorem, you got a translation from two reflections, but two reflections across two parallel lines, you will get a translation. If you make two reflections across two intersecting lines, you will get a rotation. So any rotation, you can get it from two reflections across two intersecting lines, and any translation, you can get it from two reflections across two parallel lines. Okay? And don't forget about the distances, which I talk about them here, and about the angles, which I talk about them here in the rotation. This is the second theorem. Thanks for watching. See you next time.